Bismillah Rahman Rahim. Last time we have completed or started, I think, uh, chemical bonding.
Sir, yesterday we were at metallic bonding.
Yes, metallic bonding. Yes, can you define what is metallic bonding? Yes,
Sir, so
yes,
I think
yes.
metallic bonding is the bonding between the atoms of uh, the metal elements.
Yes, metallic bonding is in the metal, right? So can
Yes,
you tell me what sort of bonding is it?
it's a bonding between. It's a bond between the two atoms where the both atoms try to complete their shell, their valence shell, so they
Mm-hmm.
transfer the electrons. And so
Mm-hmm.
in that process they lose electrons, so
Mm-hmm.
the electrons lost are free to move.
Mm-hmm.
Yeah.
So basically, metallic bonding is the bonding within the metal, right? So
Yes.
in metallic bonding, electrons are delocalized, especially valence electrons of metal delocalized, and these delocalized electrons are attracted by the nucleus of metal, right? You know that metal has positive charge, so this metal is attracted by this. These electrons are attracted by nucleus, right? Positive nucleus of metal. So this interaction is known as metallic bonding. Are you getting this
Yes.
Yes,
point?
sir.
This is metallic lattice. This is metallic lattice. This is metallic lattice. So can you tell me some similarities between diamond and silicon?
um, uh, yeah, sir. So both have the same they both have high melting and boiling points.
Hmm. Very good. And
Also they're hard.
yes, or and
Sir,
more.
sir, both of them have a tetrahedral structure.
Both of them have tetrahedral structure, correct? And
Uh,
uh, and both do not conduct electricity.
hmm, okay, uh, both cannot conduct electricity, right? So let's start metallic bonding. So first point is metals have metals have mobile electron, mobile electrons. Mobile electrons means free electrons. Free electrons. Metals have mobile electrons between positive ions in a metallic lattice. In a metallic lattice. in a metallic lattice. Known as C of delocalized electrons. Now, what is metallic bonding?
Sir, metallic bonding is the bonding between the positive ions of the metal and the sea of delocalized electrons.
Exactly. Metallic bonding is the electrostatic force of attraction between the mobile electron or delocalized electron, delocalized electron and positive metal ion within a solid metal. Now look at different metals. This is sodium. Let's suppose this is sodium metal. This is calcium. This is aluminum. This is sodium. So it has positive charge. This is sodium. This is calcium. This is aluminum. This is calcium. So calcium has +2 charge. Aluminium has 3+ charge. So in sodium, 1 delocalized electron. In calcium, 2 delocalized electron. In aluminium, 3 delocalized electron. Now, can you tell me which species has more stronger metallic bonding? Yes,
Sir, aluminium.
yes, aluminium has strong metallic bonding. Can you tell me why?
Because it has more delocalized electrons, so and more positive ions. So meaning the electrostatic force of attraction would be much greater, as more electrons are attracted with more ions, positive.
Mhm. So aluminium has strong metallic bonding because strong metallic bonding, aluminum has strong metallic bonding because it has more charge, 3 plus, more nuclear attraction, more nuclear attraction, more nuclear attraction. It has more nuclear attraction. So now first part of the syllabus is describe metallic bonding as the CO of delocalized between positive ion and giant metallic lattice. Explain in terms of structure, bonding, the properties of metal, good electric conductivity. Next is properties of metal.
Sir,
Yes,
sir, can I copy the above thing?
yes, yes. Can I move forward?
Yes,
Okay.
sir.
Okay, explain in terms of structure and bonding the properties of metal. Number one, good electricity. So property of properties of metals. Properties of metals. First property is melting point. First property is melting point. First property is melting point. Yes. What is
Sir,
your opinion about the melting point?
sir, I think their melting point is high, like very high,
Hmm.
because
Hmm.
because we know that the electrostatic force of attraction in metals is very high due to the C of delocalized electrons and the positive metal ions. So we need high temperatures to break the bond between them.
Exactly. So you can see that here we have a lot of a lot of metallic bonding, right? Now you can see that here we have C of electrons and metallic bonding. So metal has many metallic bonds. Metallic bonds in giant metallic lattice structure. Metals Metal has many metallic bonds, so it's metal cell. Point number 2, strong attraction between positive nucleus and delocalized electrons. Delocalized electron. Point number 3, a lot of energy is required. A lot of energy is required to break these bonds. To break these bonds. That's why metals have high melting point. For example, can you find the melting point of copper? Yes. Can anyone find the melting point of copper?
Sir, the melting point of copper is 1083 degrees Celsius.
It's very high. Can anyone find melting point of iron?
Sir, it's 1535 degrees Celsius.
35?
No, 1535, 1535 degrees Celsius.
Now you can see that very high temperature, very, very high temperature. Now next property is conductivity. Conductivity. Now metals can conduct electricity or not?
The cancer,
Why?
because they have free electrons.
Very good. Metal conduct electricity because they have free electrons. Free electrons. Free electrons which are free to move through the structure, through the metal structure. Next, when electron enters one end of the metal, it pushes free electrons of metal to move forward. Hence, electron flow. electricity is conducted. Is conducted. Can you tell me which conduct more electricity, aluminum, copper, or any material?
Sir, between aluminum and copper, copper is more conducts more electricity.
Now, can you find electrical conductivity of iron? Yes, tell me. What is the electrical conductivity of iron?
Sir, it says some 286 to 330 watts m minus one something.
Okay, 286. 286 to
330.
330. M minus 1.
Yes, and K minus one.
MK minus 1. Am I right?
Yes, sir. M minus one, K minus one.
M minus 1.
Yes, sir. M to the power of minus one and K to the power of negative one.
Okay. Now find electrical conductivity of copper. Of copper.
Sir, here it says 16.78 N ohm sine dot M at 20 degrees Celsius.
Not in M inverse, K inverse.
Sir, I'll find. Yes, sir, I
Find a
found it.
table.
So it's so here it says for iron also says 286 to 330.
Okay. And for copper,
Oh, for iron. Okay, so for copper, wait. Yeah, sir. So for copper it says 380.
380. M inverse, K inverse, right?
Yeah,
So
380 W M inverse K inverse.
W. So just look at the quantity or amount of magnitude of the conductivity. So which one has more conductivity?
Sir, copper.
Copper is a good conductor. Then iron. Okay. Next is
Sir,
yes.
will it like this come in the syllabus like WMK?
No, it is not in your syllabus. That's why I not emphasize on the unit.
Okay.
Next is malleable and ductile. Malleable and ductile. Yes, malleable and ductile. Malleable and ductile. Malleable and ductile. Now, can you tell me what is malleable?
Sir, malleable is like a property of substances, like they can be made into sheets.
Okay. And what is ductile?
Ductile is another property, which means that it can be uh, it it can be stretched into wires.
Okay. So malleability,
Basically, deform without it losing its toughness.
exactly, is the ability of a substance. It is the ability of a substance, or you can say that metal, to be deformed into different shape, into different shape, into different shape. For example, this is gold bar. Gold. So we can convert this gold into this bar. So always remember, gold is the most malleable metal. Most malleable metal. So jewelries are made when you are hammering it, when you are hammering on it. So we can change cylindrical into oval. So this is malleability. And what is ductile?
So it's the ability to be deformed without losing toughness,
Mhm.
like copper wires.
Okay. Now, can you tell me can you tell me the opposite of malleability? Opposite of malleability is brittle. Brittle means which easily torn into different pieces. Now, ductile. Ductile means, yes. Can you tell me what is ductile?
So ductile means it's the ability. It means to be deformed without losing toughness.
Okay. Ability of a metal. Ability of a metal
To be deformed without losing toughness.
Are you listening my voice?
Yes, sir.
Okay. So ductile means ability of a metal uh, to be drawn into a thin wire without breaking. This is ductile. Let's suppose this is gold bar. This is gold bar. So we convert gold bar into wire. Wire. So this is ductile. This is malleable. So metals are malleable and ductile. Metals are malleable and ductile. Can you tell me why metals are malleable and ductile? Any idea? No
No,
idea?
no, sir. No, sir.
Okay. Okay.
Sir, can you
Now,
go out?
okay.
For 1 second. Okay, sir.
Let's suppose this is a metal. This is positive ion. So this is layer of positive ion. Layer of positive ion. When you hammer it out or drag the layer, when you apply force, this layer move.
Sir, how does it move? Doesn't it have like,
Now
doesn't it have
look
some
at the
bond
layer.
between it?
Look at the layer. When you apply force, the layer move. That's why metals are ductile and malleable. You know that they have a layer of positive ion. So positive ion can slide over one another and take different position, right? So first point,
Sir,
yes.
but like so metals. So basically, but they can only be malleable and ductile when they are like at a low at a high temperature.
Mhm.
Is that
Just
true? Like
when you increase the temperature, malleability increases.
because you like if you have a cold piece of block, you can't
Mhm.
like make it like ductile.
By hammering you can. By hammering you can. But a lot of
Okay.
force is required. But when you heat, molecules vibrate and easily you can transform into different shape. Are you getting my point or not?
Yes, sir.
So layer of positive ions can slide over slide over each other. Slide over each other. Slide over each other. And take new position. Or you can say that take new and different position. And what about the delocalized electron? Delocalized electron are also moved with the metal ion. With the metal ion. With the metal ion. So metallic bonding is not disturbed. So metallic bonding remain. So metallic bonding remain same and not changed. And not change. Not change. Next point. Metallic bonding is not broken by hammering. So it means metals are stronger and flexible. Metallic bonding is not broken. Metallic bonding is stronger. Metallic bonding is stronger. It is not broken. It is not broken. So metals are strong but flexible. They are flexible and strong. Due to flexibility, they can be converted into wire without breaking. Without breaking. Without breaking.
Sir,
Hmm.
what do you mean by like metallic bonding is stronger? Like stronger than what?
Stronger, it means, or you can say that metallic bonding is stronger because metallic bonding is not broken by the hammering. When you apply force, metallic bonding remains same. Delocalized electron remain intact with the positive ion. That's why I wrote it is stronger.
Okay, so then that mean that then how is it flexible, sir?
Because metallic bonding is very stronger. It is, you cannot separate out positive ion and negative electrons. Are you getting my point? It is not separated. The attraction between metal ion and negative electron is not overcome by hammering.
Then how it is flexible, sir?
That's why it is flexible. Flexible means when you apply pressure on it, right? So without being breaking, they convert into different shape.
Oh, okay, sir.
That's why they are flexible, right? So
Yes, sir. Understood.
here we have metallic bonding. No. Hmm. Yes.
Sir,
Yes.
how many chapters, how many topics in this chapter, the unit 3?
Now look at the syllabus again. Yes. Here we have the syllabus. Yes. So we have complete. Yes, metallic bonding. So the chapter is closed. Now we are moving to stoichiometry. Now we are moving to new chapter, stoichiometry.
Okay, sir. Sir, how many chapter topics in this one?
In this stoichiometry,
Yes, sir.
we have three units. We have three
Okay.
units: 3.1, 3.2, and 3.3. Very important. Very important stoichiometry, right? This is stoichiometry. Stoichiometry moles. Stoichiometry moles. Very important chapter. This is chapter number 3, stoichiometry. Chapter number 3, stoichiometry. First topic is formula. Can you tell me what is stoichiometry? I need the definition of the stoichiometry. Yes, anyone? What is stoichiometry?
Sir, do you have to search?
Yes, you can search.
Okay. Sir, so it means The determination of the proportions in which elements or compounds react with one another.
Now look at the exact meaning of the stoichiometry, right? So let's suppose here we have reactant. Reactant. Reactants convert into product. Reactants convert into product. For example, A plus B gives C. So stoichiometry means what exactly amount of reactant A and B are required to react and form product. Now,
Sir,
yes, Bete.
so you mean how many proportions of A and B you need to create the
Exactly.
product C?
You can see that you can say that proportion, or you can say that mass of the reactant, or you can say that mole of the reactant.
Okay.
Now, stoichiometry. The word stoichiometry composed of two words, stoichion, 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 and matron. Matri is derived from the word matron. Matron. Stoichion means elements, and matron means measure, measure, to measure. So what is the exact meaning of stoichiometry? This is called chemical reaction. This is chemical reaction. Chemical reaction. Chemical reaction. So stoichiometry means stoichiometry means representing the exact mass or moles. Mole is the unit of amount of any substance. Chemists mostly used the word moles instead of the word mass.
Sir,
Are you getting
would you
my?
please say it again?
Now listen.
So,
Mass means gram, right? You know that if you have 5 gram of NaCl, it means you have mass, right? But chemists use the word mole, M-O-L-E, mole. Mole is the unit of amount of substance used by chemists. Are you getting my point or not?
okay, sir.
Now, definition of stoichiometry. Stoichiometry means representing the exact mass or moles of the reactant of the reactants which are required to react with each other without any wastage. Without any wastage. Without any wastage. And forming or finding exact mass or mole 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 of the product which will form or which will be formed. Are you getting my point or not?
Yes,
Okay,
sir.
sir.
Okay. So stoichiometry is represented by number one, by a balance equation. Number two, number one, by a balanced equation. Number two, in which the coefficient represent, I will explain later, right? Represent the exact number of reacting moles and forming moles. Forming moles. Example. Now look at example. Now look at the example. Let's suppose you have 2A react with B and form 3C. Now can you tell me the ratio between A and B? Yes. Can
2
you
is to
tell
1,
me
sir.
the ratio between A and B?
2 is to 1.
Yes,
2A,
that
1B.
exactly 2:1 ratio. The ratio is 2:1, and the product form is 3. This is called molar ratio. This ratio is called molar ratio. It means if we have 2 moles of A, if we have 2 moles of A, how many moles of, or you can say that 1 mole of A, 2 mole of A react with 1 mole of B and form 3 mole of C. 3 mole of C. Are you getting my point or not?
Yes, sir.
Now, A ratio B, B ratio C, A ratio C. Now, can you tell me the ratio between A and B? Yes.
Sir,
Can you
2:3.
A and B 2:1?
So A and B, yeah.
And what is the ratio between B and C?
Sir, 1:3.
1:3. Now, can you tell me the ratio between A and C?
Sir, 2:3.
2:3. 2:3. Now, question. If moles of A is equal to 2 mole, mole of B is equal to 3 mole. Now, let's suppose this is conical flask. In the conical flask, you have A and B. B is 3 mole, A is 2 mole. Now, can anyone tell me how many moles of C are formed?
Sir, 5.
5. Wrong answer.
Sir, can you repeat again your question?
Look at the question again. If you have 1 mole, if in a reactant flask you have 2 mole of A and 3 mole of B, how many moles of C should be formed? Yes.
Five mole, 5 mole.
Yes.
5 mole. I guess.
5 moles. 5 mole is the wrong answer. You know that. Now listen. You know that 2 mole of A. 2 mole of A react with 1 mole of B. So according to equation, 3 mole, 2 mole of B is wasted. Are you getting my point or not? Now look at the equation. Now look at the equation. The ratio is 2:1. For 2 mole of A, 1 mole of B is required. But in your container, you have 2 mole of A and 3 mole of B. Can you tell me how many moles of B are required? Can you tell me how many moles of B are required?
Sir, 1.
1. So how many moles of B are wasted?
Last one.
No, 2 moles
2,
are
2, sir,
wasted.
2. 2
2.
moles.
Oh, yes.
Because
Two
2
more.
because 2 mole of A require 1 mole. So 2 moles are wasted. So 2 mole of A will react with 1 mole of B. So 2 mole of B are wasted. So 2 mole of B are wasted. Are you getting my point or not?
Yes, sir.
This is all about the stoichiometry, right? So this is the introduction of the stoichiometry. Now, first topic is formula. Formula. Now, what is formula? This is the introduction. Now, I am starting the chapter. Yes, what is formula? Yes, anyone? What is formula? Any idea about the formula?
Sir, it's like a rule which
Mm,
tells us how things work, like an expression.
mm. Formula means, uh, for example, you have sodium chloride. So, formula is symbolic form of any chemical, right?
Okay, sir.
So, formula is expression. You can say that it is an expression that shows that shows the element in a compound and show the relative proportion of those elements, right? So it is an expression that shows elements in a compound and relative proportions of those elements those elements. For example, salt. Chemical name of salt is sodium table salt, sodium chloride, sodium chloride. So elements are sodium and chlorine. Elements, sodium and chlorine. Ratio 1:1. So ratio between sodium and chlorine is 1:1. Now second example is water. Water is H2O. Now can you tell me the name of the element? Yes,
Hydrogen, sir.
hydrogen and
Oxygen.
oxygen, and the ratio is
2:1.
2:1. Next example is sulfuric acid. Sulfuric acid H2SO4. Yes, can you tell me the name?
Hydrogen,
Hydrogen, sulfur
oxygen.
and oxygen.
Two,
And the ratio
one,
is
four.
2. Very good. 2:1:4. This is the ratio. Now the most difficult, calcium phosphate. Calcium phosphate. Calcium phosphate, Ca2, Ca3, PO4 2. This is the chemical formula of the calcium phosphate. Now element
Calcium, potassium, oxygen.
calcium,
3.
phosphorus and oxygen. Calcium is 3,
2,
phosphorus 2,
and it's 8.
8. Very good. Are you getting my point or not?
Yes.
Yes, sir. So the ratios is like the formula.
Yes, ratio. By combining the ratio, you can easily find the ratio. By finding the formula, you can easily find the ratio between the elements, right? Now you can also find the number of atoms. Now the next question is find number of atoms. First question is H2SO4. H2SO4. So hydrogen, 2 atoms. Sulfur, 1 atom. Oxygen, 4 atoms. How many total atoms?
7.
7.
7 atoms. So sulfuric acid has 7 atoms. Next is NH3. Yes, how many atoms? Yes. How many atoms?
So 1 plus 3 equals 4.
So total 4 atoms.
Yes.
Total 4 atoms. Now find atoms in calcium phosphate. Yes, tell me the total number of atoms.
So calcium has 3, and phosphate has 3 also, and oxygen has 12.
Calcium has
12,
3.
12.
So it's going to be 12 plus 6, 18.
Sorry, here you have 2.
No, so 6 plus 12, yeah, 18.
Calcium has 3 atoms. Phosphorus has 2 atoms.
Also 2. And oxygen has
Oxygen
8.
has
8.
8 atoms.
So 13,
So
sir.
total
13.
13. Total 13 atoms. So formula give state the formula of the elements and compounds named in subject content. Define the molecular formula of a compound as the number of molecular formula. Molecular formula. Molecular formula. These all are molecular formula. The complete name of formula is molecular formula. Molecular formula.
Okay, sir. Sir,
If you have
it's time.
molecule, sorry,
Are you ending the class?
we still have 10 minutes, right?
Oh, okay.
Or should I? What is your opinion? Should I
I
off
don't
the
mind.
class or yes? Tell me.
It's your choice, sir. Yeah, we can stop right here if you say.
Okay. Okay. So inshallah, we will start from this chapter again, right?
Okay, sir. Inshallah. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz.
Thank you. Allah Hafiz.
Allah Hafiz.